Hi, everyone. Welcome back to SAT Math Question of the Day. I always get the two confused. Okay, with Professor Emeritus Seth Chaiken, University of Albany, Joel Chaiken. We're here to help you approach SAT math questions. Here we have question 5 from a practice test. The SAT published years ago, but current for the 2016 test. And here it is, non-calculator question. We'll go with the thin black line. No, thin green line today. So which of the following was equivalent to the expression above? Just sort of FOIL it out. You can look at the different expressions. Pretty clear that this is no way. That's the answer. 45x, no way. Looks like the leading coefficient is going to be 24. So, and then as Seth and I looked at this just for a second, I know we cheated. This is the only one that makes any sense because that's the only one that includes all the terms. But you're more than welcome to FOIL it out. But that's sort of a waste of time. You could just go.
What's happening is that it's not what everyone should try doing. What everyone should try doing is foil it out in your imagination rather than on paper.
Okay.
And then think of what happens because of a couple of properties. All of the signs here are positive. There are no negative numbers, no minus signs. So when you FOIL it out, everything is going, every term you get is going to be positive. There'll be no cancellations.
Right.
So please try that in your mind when you FOIL it out, as Joel says. And I hope, should we remind people what it means to FOIL it out?
I guess so.
So you FOIL it.
Basically, it's just
give it a FOIL.
It's basically just distributing. FOIL stands for first, outer, inner, last. Okay, FOIL. But essentially, what it means in math, you have to understand what these things mean rather than the terms. Essentially, it means distributing. Essentially, what you're doing is you're doing 2x times 4x plus 1 plus 1 times 4x plus 1. But that takes too much time. But this is essentially what you're doing.
This is the foiling out business he's talking about.
Yeah.
I'm doing foiling.
Right.
Oops.
So
we are.
Yeah. Well, I did it.
And,
I did it here. This is the end. This
is this one, and this one. So there are four terms that get resulted. You pick, rather than FOIL it. I don't like FOIL. Because what does that mean if you're multiplying 3 binomials? There's a first, middle, and last. The way I rather think they shouldn't talk about foiling. They should talk about as follows: pick one from the left and one from the right, and do that in all possible ways. So pick the first from the left and the first from the right, the first from the left and the second from the right, the second from the left and the first from the right, and the second from the left and the second from the right.
Sounds like a dance.
Or rather, it's like in certain restaurants, you have a column A and a column B. And there are 2 choices for A and 2 choices for B. What you do is in all possible ways, a combination of a choice from A and a choice from B. There are 4 choices. And so you use your eyes or your imagination to think of these terms multiplied out in 4 possible ways. Of course, for the answer, 3 then needs to be multiplied by all 4 of them.
Right.
But the point is, without actually writing it out, you see every term either is a multiple of x, or is a constant, or is a multiple of x squared.
Right.
And the only answer in which all 3 possible kinds of terms, an x squared term, an X term, and a constant term, this is the only answer that has that pattern.
Right. Yeah.
And so you could pick this answer without doing any of the arithmetic.
Right. So you should be
so
able
it's cool. It's cool to pick up tricks to answer easy questions, because it appears that the SAT is salted with answers questions you could get the answer really fast,
right?
Really fast if you see the pattern,
right?
And then that gives you the time to spend on the questions where you really do have to calculate slowly and carefully and check your results.
Right. So it may not be a bad idea when you take the SAT to quickly evaluate a question. Can I do this question in like 5 seconds? And if you can, then do it in 5 seconds, as Seth said, and just do it as quickly as you can. But you only have to do, but you'd only do that to the ones that you absolutely know you can do very, very quickly. Stay away from table questions. You have a table question, you can't do it in 5 seconds. Okay, so I guess we're done with this, right?
Yeah, we did it.
Yeah. Okay. See you, everyone. We're gonna bid everyone goodbye, but we're gonna do an Ask the Seth or Feed the Seth little question today. It actually has to do with physics that came up that I had for Seth. So we're gonna feed the Seth a physics question. He majored in physics, and it's actually a physics question that comes out of calculus. So if you're interested, hang around. If not, see you. Then like us, dislike us, give us comments, and you could contact us at satmathquestionoftheday@gmail.com. Okay, so let's feed the Seth and give him a physics question that I had a question about. Seth and I already sort of talked about this a little bit, but we were getting into some heated arguments, so we figured that maybe we could discuss this so people can sort of read it as we talk. But my question for Seth is from a physics point of view. This is the answer. From the physics point of view, what are the algebraic signs of the various things in this equation? Now, okay, sorry for that little break. You'll probably notice there's something like this in the video. We had to stop the video because someone stopped by here. So we're going to restart this question from scratch. Okay, so I guess people have to be introduced. So this is a segment in our video sessions called Feed the Seth. Seth was a physics major, or is a physics major, and I had a question about this. A teacher wrote up this solution, and I had a question about the algebraic signs of these two guys. These two, the 0.4 and the -60. So I'm feeding the Seth the question. I'm going to be asking him later, what's going on here? I personally think that this should be a -0.4 and a positive 0.60, which when you multiply, no, it's not positive 60. When you multiply, you still get a negative number, right? So in the end, the answer is the same. But I think technically those signs should be reversed. But anyway, that was my focused question. But Seth, when you feed the Seth, you just don't know what you're going to get. So we're going to feed the Seth this question. I'm asking this specific question, but he's gonna talk about this, and hopefully, Seth, please just answer my question. Okay? So now go ahead, Seth. Feed the Seth.
Okay.
Oh, by the way, this is from a calculus. This is from a AB calculus homework assignment.
Okay, calculus. All right, good. Thank you. So, what's the question? The situation is car A is moving west at 50 miles per hour, and car B is moving north at 60 miles per hour. Both are headed for some intersection of roads. Okay, so we presume the geometry is something like this. And then the question is, at what rate are the cars approaching each other? But there's more data. When car A is 0.3 of a mile and car B is 0.4 of a mile from the intersection. Okay, so the teacher wrote, please don't write there.
Okay.
Yeah, the teacher put this diagram here. There's an arrow from A going left, and there's an X over it. I find that confusing. What I want to do
Ooh.
is draw a picture of the geometry of the situation. We have car A, and so my writing will be in red. Car A is at this point. The intersection is due west of car A. Car B is at this point, it's due south of the intersection.
Okay.
Now, the data of the problem says that car A is 0.3 of a mile from the intersection. So I will use what's written on blueprints or engineering diagrams.
Okay.
To indicate the distance between A and the intersection. It's 0.3 of a mile. I will similarly, the distance of car B to the intersection, we are told part of the data of the problem, this distance, which is measured north-south or south-north, is 0.4 of a mile. Okay? Now, so, and the question is, okay, so let's put more data into this. A physicist would add the additional data as follows. The physicist would put a little arrow on A, which when I do it, I try to make a little arrow, it messes up. So I'll make, there we go, there's this little arrow on A. And that arrow stands for the velocity of car A, right? And then similarly for car B, is a little arrow that stands for the velocity of car B.
Right.
Okay, and we're told that the velocity of car A is leftward 50 miles per hour. And the velocity of car B is northbound at 60 miles per hour. Okay, now, what's the question? At what rate are the cars approaching each other? So what's happening is car A is moving like along here, car B is moving along here, and at any point in time, the driver of car B can see the driver of car A and vice versa, and they can see there's a line, they can see along the line between A and B.
Right.
The length of this line is the distance between car A and car B, right? Now, let's now do geometry and draw the horizontal line from the intersection to car A, and the vertical line, north-south line, car B. And since we know on it's a small, to an excellent approximation, ignoring the roundness of the Earth, north-south is perpendicular to east-west.
Right.
So we have a triangle.
Right.
Let Z be the distance from between car A and car B. I'm not saying from A to B or from B to A, but between.
Okay.
And the teacher did put Z here with a double arrow. Okay?
Right.
Well, so perhaps I would rather on her diagram put two little arrows on here, because the arrow that represents the motion of car A is a different physical concept from the line that represents,
oh God, okay,
the placement of A compared to the origin.
Yeah.
Okay, so now we have a geometry question. The length, the length of the of the line I, the length of the line IA is 3/10, and let's call that X. And the length of the line from I to B, IB, let's call that Y. Okay? Now, from the Pythagorean theorem, okay, so what are we interested in? We're interested in how Z changes. Now, from imagining the motion, clearly the cars are approaching. Z is decreasing in time. Therefore, now this is a calculus. The rate of change of a signed quantity is called with a differentiation variable. In the case here, time is called the derivative.
Yeah. So
we're interested in this formulation. X, Y, and Z are all greater than 0, and we are interested in. We are interested in. Well, how with the rate at which they are approaching. Approaching means the distance is diminishing.
Right.
Now, in ordinary English, if we ask, what is the rate at which two cars who are approaching each other as if to crash, at what rate are they approaching? We would give you a positive number.
Right.
Right? So we're interested in Z is a positive number, and in this situation, we will see that Z is decreasing. And so we're interested in is dz dt with calculus, and we expect we should get a Z is decreasing. Z is decreasing, and so we should give a sign for which dz dt is 0. Okay?
You mean less than 0?
Yeah, but the whatever the dz dt in this formulation should be negative, but the answer to the question should be positive.
Seth, I just want to know.
Okay. So let's do the math. Hold on. Let's do the math. Okay, let's do the math. So, let's do the math. So X is positive. It represents the positive measurement of the distance between the origin, the intersection, and A. Right. A is approaching intersection. And so the data that we're given is dx dt equals -50.
Right. Okay. We all agree on that.
And dy dt is as she says, dx dt is -50, and dy dt is -60. Okay. So then they use calculus to find dz dt.
Right.
Right. Well, now there's indeed. So Z is a positive number. Physically, it is decreasing.
Right.
Therefore, to write that in calculus, to say that it's decreasing in calculus, we would say the derivative is negative.
Right. Okay.
And the answer comes out to be negative.
Yeah.
Right?
Right.
Now, I think there is a problem here because the calculation is of dz dt. If you replace Z by a new variable, -Z, then the new variable derivative should change sign.
We're not
However,
doing any of that.
if you replace z with negative z in the Pythagorean theorem, the sign change goes away.
Right.
And so, to be really careful about the sign, what you should write is you want to find z. You want to see how z changes. So you write from geometry, z equals the positive square root of x squared plus y squared.
Okay.
And now you could directly take the derivative of this. Shall we do that?
Seth, you're going off the deep end.
No. When you differentiate this and then plug in dz dt equals this, dy dt equals this, you're going to get the same thing.
Yeah. Seth, you're going
Okay.
off the deep end.
Great.
Just
So that's my answer. I agree with the geometric setup. I would merely make the change. I would put double arrows for the blue arrow and the purple arrow, and I would put a separate little arrow here to represent the velocity of A, and a separate little arrow that goes up to represent the velocity of B. Now, the physically, the arrow on A representing its velocity tells us right away that X is decreasing.
Right, okay.
Because the arrow is pointing in a way to shorten the length of the top of the triangle.
Okay.
And similarly, the arrow is pointing into the vertical line, and that indicates the z is also decreasing, which is common sense. The distance from A to the intersection is decreasing, so its derivative is negative. Distance from B to the intersection is decreasing. Its derivative is negative.
Got it. Okay, so
I think that's all I have to say.
So in other words, you're saying okay, fine. Now, so the bottom line, after all that discussion, the bottom line is you are happy with the way this is set up because it is self-consistent. The way this solution is self-consistent, what she's doing is she's using common sense. She's saying that X is getting smaller because it's approaching the intersection. Y is getting smaller. It's approaching the intersection. So she's putting negative signs on these guys, and the distances are positive. So that's why she does it this way.
However, all I would add is the answer in a box.
Yeah.
Rate, answer.
Okay.
In a box.
Yeah.
Is 78 mph.
Oh, I see. The rating.
That's the answer to the question, which unfortunately she did not write down.
Right, because when I looked at this
what she did was formulate a different problem in geometry and calculus and gave the answer to that question.
Right. Okay. So let me talk for a few minutes. Okay, fine. So essentially, when I looked at this question, I didn't understand it either. I changed this to at what rate is the distance of the cars changing? At what rate are the distance of the cars changing? Okay. Now, if you write it that way, I think it is a negative number because the distance is going down. Yeah. So that's how I think it should have been.
Right. Written. The rate of change of the distance.
Right.
Is different from the speed at which they're approaching.
Let me just make a real, but nobody, I doubt anybody who's doing percent problems at that level is even listening to this thing. But this is very similar to the type of question where, what is the percent decrease of something? You always say positive number, right? If you say, what's the percent decrease of something, use a negative number, you got it wrong. The percent may be negative in the calculation, but if they say, what's the percent decrease, you better answer a positive number. Anyway, let me get back to this. So I see your point, okay? I see your point. But let's just hear me out on this one, okay? I'm on the physics point of view. Now, the physics point of view, if you consider this the origin, then this is the negative x direction. Okay? So
Yeah.
that explains the negative 50. This is the positive y direction. Okay? Because you have xy. Therefore, should be, as far as I think, this should be positive. But the distance,
Wait a minute.
here should be negative.
The velocity.
But the
Sure.
distance should be negative because it has a negative distance.
Yeah.
So therefore, I'm arguing from the physics point of view. I can't stand when Zeitboard freezes. Oh, it's so frustrating. From the distance point of view, I think the point 4 should actually be negative. The velocity going toward the intersection because you're going up should be positive. In the end, you get the same answer.
Yeah, so, sure. It depends on it. You define. You could use a different variable.
Okay.
To represent how the relationship between the position of B and the origin.
Right.
If you use negative of the old x, that's fine to represent the coordinate of car B in a right-handed coordinate system. But then you have to be careful to choose the derivative of the y coordinates to be positive.
Right, because
again, the little vector is pointing upward. That be in a right-handed coordinate system. That means its y coordinate is positive.
Right, which means that if you're below the ground, you're actually starting at a negative coordinate. Okay, so I think so big lesson here is it really comes. First of all, you have to be careful. You really have to be careful. You really have to think these problems through. And you could think of it from the casual point of view, which is the way she did it. Or you could think of it from the technical physics point of view, which is the way I looked at it. In the end, you get the same answer. Okay?
Yeah. Well, there's one more thing you have to be careful about. This square root, the squaring could mess up the sign. And so when approaching this problem, you need to pick the square, whoever you're doing it, you have to choose the sign so that it's realistic.
Yeah, but
a way of mechanically doing it is, rather than this sign ambiguous relationship between X, Y, and Z, is to give the precise relationship among positive quantities that comes from the red triangle. Now you could differentiate Z at points X and Y would pick positive numbers. The chain rule will express dz dt in terms of dx dt and dy dt. You need to plug in that the x dt and dy dt are negative, and then it will come out with the correct negative derivative for z.
Right. Okay.
If you were to use the negative square root here, the calculations would be the same, except you'd come out with a positive derivative for z, which is not what the problem is modeling.
Right. Okay. I think we're done.
Yeah.
Okay. I hope people got something out. Well, probably not. But now I certainly see the point of view that, from the teacher's point of view, that if you're consistently doing it casually, the teacher's right. If you do it from a physics point of view, you have to technically what I'm right.
Well, there's another thing I need to say about the physics point of view.
One more thing.
From the physics point of view, what we're looking at is the relative velocity of, say, A relative to B projected onto the unit vector from B to A.
Okay, forget it. We're way over.
That's the physics point of view.
Yeah, okay, but fine. Okay.
Yeah,
okay, We're done. Okay. Right. Have a great day, and we'll see you next time we meet, which should be over the weekend, after the weekend. Okay, everyone.
Yeah.
Hope you got, well, we did the math SAT question, and this was sort of a feed the Seth. And when we feed Seth something, he's got to digest it first.
Yeah, he has to digest it. No, you feed him first, and then he digests it.
That's right. First we feed him, and then he digests, and then he spits back out what he digests.
All right, well, you don't want to talk any more about the physics of it.
No, I don't. I definitely don't. I think we did enough of the physics. We did enough of the physics. We did enough. Okay. Okay, ready? Time to go?
Bye-bye.
Oh, bye-bye. Seth's a little upset about this question.
Yeah. Well, here we go. Here's my addendum for you.
Fine.
Yours eyes only.
By the way, we're still recording.
We are?
Yeah.
Oh.
I didn't stop the recording.
Well, should I tell you what's for your eyes only, or should we actually stop the recording?
What do you think? How long is it going to be?
I don't know, half a minute.
Okay, yeah, definitely. Let the world know.
Let the world. Okay, from a physics point of view.
Between brothers.
Take the physics point of view. Consider this equation here. This equation here. Maybe you could zoom in on it.
Which one? Which equation?
The one, can you see my pointer?
Not yet.
It's the one that says 2x dx dt plus 2y dy dt.
Sure.
Zoom in on that. Great. Excellent. So look at this equation. Now, of course, cancel out the 2's.
Right.
Get rid of the 2's. Cancel them out with 1's.
Go ahead.
Right?
Remember, 30 seconds.
Divide both sides by z.
Okay.
This becomes a 1. Right. What we get is dz dt. And now we're going to do something in physics. Is the dot product.
Seth, come
on. I told you. It's the dot product between a unit vector and the velocity vector.
Okay.
But end of physics.
Okay, that's it?
I said end of physics.
End of physics. Okay, so you guys can look up in a good pre-calculus book like by Stewart what a dot product is. Okay, good. Go to the Stewart pre-calculus book, and even go to the Stewart calculus book, and you'll see what a dot product is between vectors. Okay, but that's college. That's college physics, and most people watching this video are not in college yet. Okay, everyone, have a great day. Bye. Want to say goodbye, or are you shell-shocked? Seth,
goodbye.
Bye.
Goodbye. Bye. Have a good day.
Bye. You still can, right? Bye.